the thing that we want to look at is just review some basic graphing. We do a lot of things with functions and their graphs in calculus, so you want to have a pretty good background for different types of functions and their graphs, okay? One of the big topics in college algebra is how you transform. You learned how to take things, move things left to right, up, down. You took trigonometry, you still did the same thing. You did phase shifts, you did stretching and shrinking and lots of transformations, so you should have a lot of experience with that. So first of all, if you take like a basic quadratic function, y equals x squared, that's represented by the dashed line you see on there. Okay, what I'm doing on this is I'm moving this up 4. So out of the 4 choices, which one is the correct equation for that graph if I move it up 4? A, B, C, or D? What? D. Okay, yeah, D. The idea is this one, whenever you add or subtract away from the function outside of it, you're going up. Now I want to just kind of have you make a note of these and see what you remember. How about x plus 4 to the second? That's a parabola, but what does the plus 4 do? Is it to the left? Okay, that's because it's inside the function, and the plus, it seems like it would move it to the right, but it doesn't. Okay, how about B? What does the minus 4 do? Takes it down. Okay, that would be down 4. And how about A? Right 4. Okay, so you want to remember this kind of stuff because there's going to be times when you need to quickly do a graph. Without getting a graphing calculator out, you just kind of quickly draw a sketch of things like that. Okay, so the idea is, and I'd like you to write down just this little visual, if you have f of x plus or minus a plus or minus b. Okay, now see, if you're inside the function, inside of whatever that function is, what you're doing is you're going left or you're going right. Okay, if you are outside of the function, then that's when you do up and down, because what outside is doing, it's adding or subtracting. It's making, this number is making, the number b is making y's get bigger or smaller. So that's outside the function, that's going to be up or down. So if you got a good background for that, then you're in good shape. If you need to review that, we will be doing that throughout the semester, some graphing, so a lot of times I'll do some quick review on that. Okay, so the next one, what did I do? I switched this to the right 2. So which one is the correct equation on this one? Okay, A, that is correct. That's right, like that. Okay, all right. Okay, let's go to this one right here. Okay, if you graph negative x squared, what does this negative do to the graph of the parabola? It reflects it over the x-axis. So this one is reflecting over the x-axis like this. So there's 2 things that have happened on this problem. Okay, we've reflected, and it's over x. So we're reflecting over the x-axis. But the other thing that we're doing on this problem is it looks like we're moving that graph up 5. Okay, so you're reflecting and going up 5. Which one is the correct equation on A, B, C, or D? C is correct. There's your reflection right there, okay? But that is outside of the function. See, it's not inside of something squared. It's outside of the operation of squaring, so that's going to take you up 5, so that's correct. Okay, this one right here would just be down 5. What would B do? Be left 5, and then D would be taking you to the right 5 like that. So you just want to get real clear. It works the same way on all functions. Okay, like in trigonometry, if you have the sign of x plus pi, since that's plus pi is inside the function, that's what phase shifts. That's what makes things go left and right. Okay, all right, now here's one that's, looks like we got 2 things. The dashed line is just y equals x squared. Okay, it looks like we're moving to the left. Help me out. Left 2? Up 4? That's what I see. Does that look right? Okay, so which one is the correct choice on these? Looks like B. Okay, yep, that's the correct one, because that's your left right there, and then that's your up 4 like that. Okay, so I just wanted to kind of review up, down, left, right, reflect over x-axis just to begin with. Okay, you guys remember that from your background? Okay, all right. Now this is just a kind of a diagram. One thing we do in calculus a little bit, you may have done some of this in college algebra, is a quadratic function is what represents how projectiles travel in Earth. So even if you go to the water fountain, next time you go to the water fountain, a parabola comes out. Okay, you're drinking from a parabola. You shoot hoops, you play golf, those are all parabolas. We know mathematically that's the way gravity works, and that's the way it works on Earth. Okay, it works the same way on like the moon, but it's a little different because of the gravity is different. But it follows a quadratic equation, which who would have thought? That's the way it works. Okay, so a quadratic function, one thing you would have learned in college algebra is this is the general form of a quadratic function. And a couple of things like, one thing that I want to just kind of show you on this, you don't need to write this down, but just pay attention to this. So we've already talked about the k is what does up and down. And get in your mind that it's outside the function. I'll keep saying that because that's the big picture you get about all functions. Okay, if it's inside the function, then it's left, right. Okay, this number right here is going to multiply y by a. So it's going to make the y values get bigger. So if the y values get bigger, it doesn't move you up or down. If it multiplies, do you know what it does? Stretches. Okay, you probably learned in college algebra vertical stretching. So this thing right here is either going to stretch or it's going to shrink vertically. Okay, so anytime that you have a number right directly inside of any function, that's what happens. In trigonometry, what did we call that number that stretched the sine and cosine wave? Amplitude, right, that's what an amplitude is. Okay, it's a vertical stretch shrink factor is what that is. Okay, and then if a is positive, that just means you have a parabola going up. If a is negative, it causes a reflection like that. So that's just kind of the general basic form. We call that the vertex form of a quadratic function. So it looks like that. Okay. Linear functions, y equals mx plus b. You should have that down hopefully. But I want to show you more specifically on a linear function what a table of values looks like. What happens on what makes a function linear as if x goes up, then y goes up the same way. Okay, so what's happening on like a linear function, let's see, this one right down here, this table is a linear function. So I want you to notice that, whoops, that happens every now and then, it jumps around a little bit there. Okay, that looks like that's going up 1, like that. Well, what's happening over here? That looks like that's going up 2 every single time, isn't it? So that's what happens on linear functions. If x goes up 1, y goes up something. It doesn't necessarily have to go up 1. It can go up by 5s, but consistently, that's what makes a function linear, okay? So if you looked at this situation over here, this one's going up 1, but see, these things are going up different. So this table, you might make a note, is not linear. So linear functions would kind of be like, I have 1, 2, 3, 4. I might have 5, 10, 15, 20. That's what makes it linear, okay? All right, you're familiar mostly with y equals mx plus b, m is the slope, y is and b is the y-intercept, okay? So that's stuff that you want to review as well. Okay, next page, I just wanted to kind of just have a couple of graphics that are there to kind of help you. It turns out that slope is a huge topic in calculus. Okay, we'll talk about slopes of tangent lines in calculus all the time. So the slope is really, really a big deal in calculus. So you got the slope formula you want to review, and then you want to kind of review these things like this. You've got a negative slope going down, positive slope going up. Undefined slope is when you're vertical. And no slope is, oh, that's not right. I can't believe, I took that off the internet. That is totally wrong. That is a slope of 0. I see stuff on the internet sometimes it's wrong. That is totally wrong. Back, you know, a lot of algebra books say this one is no slope. the way you should do that is that's zero slope, and that's undefined slope like that. Now I want to just kind of see if you guys know what these equations would be. On this one right here, it goes through the x-axis, and it goes through x equals -2. So you want to write that down. That's the equation of that line. If it's vertical, it's always going to say x equals a number. It's not going to have a y value in the equation. How about the equation of this fourth example? What's that going to be? Y equals 2, right. Okay, if it goes through the y-axis, then it's y equals a number. There's no x in that equation. It's just y is always 2. That graph is always 2 units above the x-axis. Y is always 2. That means y is equal to 2. Okay? Now, if you look at this one right here, you have y equals mx plus b. The y-intercept is this thing right here. So b is going to be equal to 2. Okay, so I'm going to have b is equal to 2. Now, if you do the slope, if you just kind of count up points, it looks like it's got a rise of 1, and it's over 1. So it's going up and over. So the slope is going to be 1 over 1 or 1. Okay, so it's rise over run. So the equation of this line is going to be y equals 1x plus 2 like that. That's the equation of that line. Okay, and then this one right here, you would have a y-intercept again of 2, but this time, what is the slope? Just count it out in your head. What's that going to be? It's negative this time, because what's happening on this is you're going down 1, and you're going to the right 1. So you're going down, which is a rise of -1, and the run, since you're going to the right, is positive. So that would be -1 over 1, which is -1. So your equation on this is going to be y equals -x plus 2 like that. Okay? Now we're going to review linear functions quite a bit when we start getting into the calculus. I just want to kind of give you a chance to review slope, review graphs, and that kind of thing like that. So when we get to that point, you'll have a little bit better background for that. Okay, let's look at this number 7. Let's match the equation with the graph. First of all, what is the y-intercept of my graph? Yeah, -3. So that's what b is. So b is -3. So that would mean that I can forget about that one. It can't be that one. Okay. Does this line have a positive slope or a negative slope? Sloping up, so it's positive. So you can forget about c, because that's got a negative slope. It's got to be one of these two right here. So you just need to take 2 good points. Okay, I think there's 2 good points right there, it looks like, there and there. So it looks like I'm going 1, 2, 3 up, 3, and then it looks like I'm going 1, 2, 3, 4 to the right. So what's the right answer? B. Okay, you have rise over run, up 3 over 4, so it's 3/4 x minus 3 like that. Okay, so you just want to familiarize yourself with linear functions and how they work. You do a lot of graphing here in the beginning of the semester with tangent lines, so you want to make sure that you remember how to quickly and efficiently graph a line. Any questions so far? Okay. All right, let's see. Now, here's the big deal. I misspelled this, first of all. I do that sometimes. This is called a piecewise function, and this is huge in calculus. And when I've taught college algebra in the past, piecewise functions tends to be an area that students don't do so well with. It's a big problem area. I find it all the time. When you do a piecewise function, you're doing more than one graph. You're putting a graph together. It's defined in different pieces. So this is just some picture I pulled out of the internet. The idea on here is a piecewise function has 2 parts. The first part is 2x plus 8. Now 2x plus 8 is a line, right? It's y equals mx plus b. But the key thing is the graph only works when x is less than -2. That's the reason I have that dashed line there, because notice this line does not extend on forever. It's to the left of -2. So what's happening on this, that's the first piece of that piecewise graph, okay? The second piece is a quadratic. That's a parabola. I don't have the whole parabola. Students all the time put the whole parabola in there. You draw the parabola starting at -2 and then for x values greater. So when you have a piecewise function, that's one piece, and then your line's your other piece. Okay, you guys remember working with that? Some in college algebra? We don't do much of that in trigonometry, but we do quite a bit of that in college algebra. You have two functions defined over two intervals. So you should have two different graphs on that. And the reason we have these dashed lines is because that's what students do all the time, is they make the parabola go forever and do that. Now let me ask this question. What if you made a mistake and you drew the graph like that? Is that a function? No, it failed the vertical line test. Okay, so the thing is, if we're talking about a piecewise function, you better pass the vertical line test. Okay, whoops, I press this button on here sometimes and it messes up. That's the reason you don't do that, because if you did, it wouldn't be a function. Okay, does that make any sense? Okay, now we're going to graph a few of these and just kind of practice, because actually in our class, Thursday's class, we're going to start working with piecewise functions. Okay, so here's a piecewise function. First of all, if you have a line that's horizontal, you just say y equals whatever the y value is. So what would be the equation of this graph right here? That would be y equals 2. And then how about the other one? Y equals -2. Okay, like that. Now I'm going to zoom on this a little bit. This is another detail that you have to have. This is an open circle. So that thing right there is open. And then this thing right here is closed. So when you write your piecewise function, you got to write it real carefully. So what you typically do is you say f of x, then you have like a half of a brace. The first function is, we just say 2. We don't have to say y equals 2, because that's what f of x is. But what is the value of x on this particular line? What kind of numbers is it? It's numbers less than 0, right? Yeah. Here's x equals 0 is right in the center, so this line doesn't work for x's that are bigger, that are positive. So what you would say is, you would say x is less than or equal to. Why do I say equal to? Because it's a solid dot. So you got to say that. Okay, so when x is less than or equal to 0, you're on that line. Okay, then you go to -2, and what kind of values of x do you use there? Things that are greater. Now, do you say greater than 0 or greater than or equal to 0? Greater than, because you've got a bubble. Okay, so you got that. So there's a big difference between greater than and greater than or equal to. Okay, so you got to remember those little details as well. So that matches up with, which one? Is that B, it looks like? So that's just kind of a basic piecewise function on here then. Okay, any question about that? Okay. Okay, let's see if we can kind of match this one up here on this number 10. Okay, so first of all, this equation right here, the line is going to be y equals 2. Okay, that's what that's going to be. All right, and then this one is going to be a line, but this is going to be in the y equals mx plus b form here. Okay, so the y-intercept on this, well, there's a couple of ways you could do that. You could keep counting the slope and figure out where you are. This one I need to zoom on this so I can see this a little bit better. But if you do this, it looks to me like if I go down 2 and if I go over 2, then I'm going to get to the next point. So we'd have a rise of -2 because we're going down, and you'd have a run of +2. So if you extended like that, well, the opposite of down and over is up and to the left. So if I go up 2, left 2, then I'm there. Up 2, left 2, I'm there. So it looks like that thing would have a y-intercept of 2. Okay? So the equation of this line right here, that would be y equals, and again, your slope is rise over run, so that's -1 times x. And then your y-intercept on that is +2. So what you have is y equals 2 is that line. Okay, y equals -x plus 2 is this line here. Okay, like that. So those are the two pieces we have in the piecewise function. Okay, so the way you write this is you write it like this. You say f of x, then you write your brace. The first function, you're going to say 2, comma, what? X is what? less than or equal to 4. Okay, that's the boundary right there. Okay, see, 4 is where it all comes to an end. 4 is where that break is. So since it's a solid bubble, you say x is less than or equal to 4 like that. Okay, the second function is negative x plus 2. Okay, like that. And then what do you put next to the comma? X is greater than 4. Strictly greater, no greater than or equal to. So you go like that. So that would be your answer like that. So be cautious about the difference between less than and equal to and just greater than, like that. Okay, the bubbles and the solid dots. Okay. Any question on that? And how I figured out this? Is everybody okay how I got negative x plus 2? Rise over run for the slope. Count out the y-intercept. That's stuff that you want to remember from your background, okay? Okay, now we're going to do a graph of one function, and I'll show you kind of how I want you to do this one. So, first of all, when you see this x less than 1, x greater than 1, now that's kind of a boundary right there, okay? That's where you're going to have a break in the graph. You guys do not need to put this dashed line because that's not a part of this graph. It's just kind of a barrier where the two functions are going to break. So let's look at the second one because it's easier, okay? How do you graph f of x equals 2? I think I've already done that 2 times. It's just a line that's horizontal that goes through 2. So what you're going to do is you're going to go to x equals 1. You're going to put a solid dot because x is greater than or equal to 1. So you're going to do that. Then you're going to draw just a horizontal line like that. And you got to put that arrow to show that it goes on forever. So that's the first piece. The second piece is this part, which is really f of x or y equals negative 5 minus x. Okay, what is the significance of that negative 5? That's the y-intercept, isn't it? Okay, so you have a y-intercept of negative 5, so I'm going to put a dot there, like at negative 5, like that. And then what's the slope of this line? It's the number in front of x, so it's negative 1 over 1. It's rise over run. That would tell you that you go down 1, and then you go to the right 1 like that. So what I'm going to do is I'm going to go from the y-intercept, down 1, right 1, and then I'm going to put a bubble there. Why am I putting a bubble there? Because it's less than. It doesn't say less than or equal to 1. It says less than 1. Then you can just kind of go backwards. The opposite of down 1, right 1 is up 1, left 1. So you can kind of go like that. And then ultimately this graph, if you kind of take it, there's this button. If I accidentally hit this button sometimes when I do this. So that graph is going to go something kind of like that. So that's your final result. You've got the two graphs. Okay? Now notice, this thing is a function, right? It passes the vertical line test. Even right here, the other thing I want to mention is, even if you take a vertical line right there, how many points does that go through? 1, because that's a point, that isn't. The hole is not a point. Okay, so even right there, that passes the vertical line test. You see what I mean? So that's how you catch mistakes. If I give you a piecewise function, make sure that your result passes the vertical line test, say. Okay, that's the idea. Okay, is there any problem, anything with that? Okay, now that you want to get pretty solid on this because we'll be looking at this in the next class. So I'm going to do one more piecewise function and kind of show you how we're going to look at this one. First of all, the boundary is 0. So I'm just going to put a little, just to help me, I'm just going to put a dashed line going through x equals 0. That's like the y-axis. That's the boundary of the two functions. Let's start by graphing this one. Okay, so if we were to graph out, this is g of x this time, g of x equals negative 4. Well, how do you graph that? That's a horizontal line, but x is greater than 0, so that means, and it's greater than or equal to 0, so what you're going to do is go down to negative 4, put a solid dot, and then you're going to do a horizontal line like that. Okay, so that's what the graph of f of x equals negative 4 is. Okay, start at 0 and then go to the right. Okay, the next one, from your background, what does an absolute value function typically look like? It's like a V shape, okay? What I'm going to do on this one, I think students oftentimes do better, unless you've got a real good background for this. I'm going to make a table of values. And we're going to work out y equals x minus 4. So what I'm going to do is this. This is the place where students are bad about messing up on this problem. Since 0 is the boundary, I'm going to go ahead and put 0 there, but I'm going to put a little note to myself that I have an open interval there. Then I'm going to use negative numbers because that's what the problem says. Your graph of the absolute value function can only use negative x values. So I'm going to use like -1, -2, -3, as many as I want, and then we'll have a good graph doing that. So what I do now is I just do plug in x. So I do absolute value of 0 minus 4, which is going to be -4. Okay, then I do absolute value of -1 minus 4. What is that, by the way? It's -3, because you got to do the absolute value. You got to do 1 minus 4, so that's -3. And then absolute value of -2 minus 4 is going to be -2, and so forth. Now you got a pattern, so you could fill it in. So what you want to do now is just graph these points. So we have 0, -4. Well, that connects, doesn't it? That connects with that line. So you don't have an open bubble anymore because it connects. Then you have -1, -3. Then you have -2, -2. And then that's just going to be that second half. Boy, it's so hard to draw lines on this thing, so it's going to go like that. So that's the graph of your piecewise function. They connect each other because what happened is when x was 0, y was -4, so it matches that other graph like that. Okay? So that's piecewise functions. Right? It is a function. Doesn't that thing pass the vertical line test? Yes. Okay, so you must end up with a function. Don't make this blue line go on forever because you don't have a function anymore. You're violating the rules of the problem anyway. Okay, any questions there? Okay. All right, now I'm going to do, I think, one more graph, and then we're going to review just a few other things. We kind of go to 1.3. I want to remind you how to do a problem like this. You can do a table of values on this, or you can just do transformations. Okay, so one of the things that you have is if I had you, we're going to start by just graphing y equals absolute value of x. When you get into higher math, one of your goals is if you need to do a graph, be able to do it fast and efficiently. So let's go ahead and make a table just for absolute value. I'm going to use 0, -1, -2, 1, and 2. Now, some of you guys said, you remember the absolute value is like a V shape. Okay? So what you're doing is you're just doing the absolute value of x. So that's 2, that's 1, that's 0, that's 1, 2, like that. So you're doing an absolute value. So what I'd like you to go ahead and do is go ahead and just plot these points, like -2, 2, like that. Then you got, and I think I kind of missed a little off track on that one. So we're going left 2, up 2, left 1, up 1, 0, 0, 1, 1, and then 2, 2, like that. Okay? And then you don't really have to put a dashed line on there, but that's the starting point. So what's happening on these points is one thing I'd like you to do. When I teach college algebra, I kind of teach it this way, and a lot of times teachers don't teach it this way. So we're going to do the -6 is inside the function. So what does that 6 do to that V shape? Takes it to the right 6. So just write down a chart like I'm showing you here. Right 6. The -5 is outside, so what does it do? Down 5. If you're outside, adding and subtracting, it goes down like this. Okay, now here's what we're going to end up doing on this then. So what I'm going to do is we're going to transform the points like this. We're going to take this x value and take it to the right 6. So if you go to the right 6 of -2, you end up at 4, right? Okay, go to the next one. Okay, if you go 6 units to the right of -1, where are you? 5. 6 units to the right of 0 is 6. Now you see the pattern, don't you? okay? And these things stay the same. A lot of times students are not taught this way, and to me this is the best way to ultimately get students how to understand this. That minus 6 right there, it changed x. It doesn't affect y. That thing right there is doing nothing to y. It's only changing x, where x is located. Now what you're going to do is you're going to go down 5. So what you do now is you just write down the same points. The x values are not affected by that 5. So I just write those down like that. And then what happens is all of these y values go down 5. So 2 minus 5 is negative 3. 1 minus 5 is negative 4. 0 minus 5 is negative 5. 1 minus 5 is negative... Whoa, am I off track here or something? I am. You know how I caught that? Because I know there's a pattern that's going to go on this. So what's 1 minus... Let's see. 1 minus 5 is negative 4. Okay, like that. And then... Oh, no, we're doing an absolute value function, so I'm okay. Okay, so we got 0 minus 5 is minus 5. Then we're back to 1 minus 5 is negative 4. And then 2 minus 5 is back to negative 3. My apology, okay? So what I'm doing is all the x values move to the right 6, then everything goes down 5. Yes?
Is that x, when x equal to 0, is that supposed to be 0 or what?
What, right here? Are you talking about which point? Are you talking about this one?
Yes, when x is 0, is it supposed to be 1?
Well, that's what I'm doing in this table right here. The table I've got in red, that's the graph of y equals absolute value of x. Okay, so what's the absolute value of 0? It's 0. Okay, these are the original points of a basic absolute value. What I did is all the x values got bigger by 6, and all the y values got smaller by 5. Okay, now plot these points out. Go ahead and just plot this group of points out right here, and then you'll have where this is translated to them. So I'm going to graph 4, negative 3, go over 4 down, negative 3, and then I got 5, negative 4, and 6, negative 5, and then 7, negative 4. So you're going to get that V shape, see? And then you got 8, negative 3, so roughly it's kind of doing something like that. So every point gets moved to the right 6 and down 5. That's the way the math works on that problem, okay? One of your goals, again, is to know elementary functions and to know how things transform so you can visually in your mind know what the graph looks like and be able to create it pretty quickly and efficiently like that, okay? Okay, any issues with anything on that with anybody? Okay. Okay, let's see, the last page I just had, I'm not going to go over this. This is just generally some of your elementary functions, absolute value, square functions, square root functions, things that you would have learned in the past. I do want you guys to write one thing on here just one more time because this is super important. When you're dealing with all functions, what does that h do? If you're adding and subtracting h, you're inside the function, what does it do to the function? Left, right, okay? So I want you to just write a note on that. You're inside the function, so that means you're going to go left or right. Okay, what does the k do? It's outside the function, so what does that do? Up, down. You're making y values getting bigger. That makes y get bigger. Okay, the a, what that does is it multiplies, and the best way to write this out is it multiplies y values by a. Okay, that means that the y values either get bigger or smaller depending on the size of a. So what that does is that is a vertical stretch or shrink. Okay, and these are just kind of your fundamental transformations that you should have learned a little bit in pre-calculus or a college algebra class. Just get that in your mind because you're going to see that over and over again. Works the same way it did in trig too. Everything's the same. Okay, any questions? Okay. All right, now I'm going to finish up by just kind of starting a review with couple things on 1, 3, and then we'll kind of finish our review next time. Just the thing on this is logarithms, and sometimes I'll see in calculus some issues show up from the background, so I just want to kind of address some of these. So what I'm going to do today here is just kind of work on the inverse of a function and drawing a picture of it. So let me just kind of see what you all remember on here. I'm going to zoom in on this graph, and I'm going to find like 3 good points because it's a line. Okay, one point is that point right there, which is 0, 0. So let's write that point down. Another good point, and I'm searching for real good points if I can possibly find them. I like this point right here, which looks to me like that is, help me out now because I don't see real good sometimes either. Is that 3, 9?
Yeah.
Okay, all right, very good. It's hard for me to see that. I'm going to zoom a little bit bigger one more time. And then this point right here, I kind of like this point. That looks like that is -3, -9. What do you think? All right, tell me if I'm seeing good or not. Okay, all right. If I want to make an inverse, which you did this in trigonometry and did in college algebra, what do? You interchange the coordinates. So let's also do this. Let's do points on the inverse. So f inverse of x is represented this way. Well, 0, 0 stays the same. Okay, this point, however, is going to go to 9, 3, and this point right here is going to go to -9, -3, like that. Okay, now let's plot those points. An inverse is real simple. X and y get interchanged. So you'd still have 0, 0, but now you would be over 9 and up 3 like that, and then you would be left 9 and down 3 like that. Okay, then you've got your line that you can kind of draw like that. So that's actually your graph of your inverse is like this. So this is f of x. That's what I gave you. That's f inverse of x like that. Okay? Now let me ask you if you remember this or not. That is symmetric. Do you know how it's symmetric? Good. Y equals x. Exactly. So you might put a note there that these two things are symmetric about the line y equals x. And y equals x is just like a line that goes at a 45-degree angle like that. So you might just kind of sketch in a dashed line y equals x, just to remember that. That's the way inverses are. So like if you had a piece of paper and if you folded this over that dashed line, then this thing would match with that and so forth. So it's just kind of, you always have that symmetry in an inverse. Inverse is a really big deal in all of math, and it's a real big deal in calculus. And inverse, you can think of operations. Like, for instance, one thing that you learned in trigonometry is what do you have? You have a sine of x and you have an inverse sine. You have a cosine and inverse cosine, and they're both backwards of each other. They're reversing the operation in the thought process. So we're going to do that with calculus with something we call differentiation and integration. Those are two kind of inverse ideas there. Okay, let's run through a couple more of these, and just kind of, I'm going to probably just finish up a couple more examples here to finish this up today. So let's do kind of the same thing on this one, just kind of draw an inverse and just kind of put this together. Let's use the point -4, 0. Let's use the point 0, 2. And let's pick one more. I kind of like this point at the end. I'm going to say that is that 10, 4?
11.
What? Oh, 11. Okay, that's why I keep asking. All right, 11, 4. Okay, is that better? Okay. All right, so that just means on the inverse, you're going to have 0, -4. You're going to have 2, 0. And you're going to have 4, 11 like that. So go ahead and plot those points out. So you're going to have 0, -4 here. 2, 0 is over 2. 4, 11 is over 4. Then way up 11 like that. So that means that graph is going to do something, that's not real good, but kind of get the idea on that. It's going to go like that. Okay, so I've got that point. So that would be kind of how the graph goes. I didn't draw that real well, but the idea is, can you kind of see that if you graphed y equals x, do you see how the symmetry would look on that just visually? Okay, the idea is the same. If you fold the paper over that dashed line, those two graphs should come together. So you basically have two graphs. You have the graph I gave you, which is that, and then the graph that we created like that. Okay, so that's how that goes. Any question with that? Okay, inverses are very simple when you're doing graphs. You're just interchanging the coordinates and sketching out a graph. One other thing that does happen sometimes is on this example 3, I'm just going to take a couple of points and estimate a few things on here, and I'm going to kind of cheat on this a little bit. I'm just going to say that that point right there looks like 2, 2, and this point right here looks like it's negative 2, like that. And then I'm going to say this point over here, again, I'm cheating a little bit because I'm trying to just kind of get the idea here. Let's say that point is like 10 and maybe it's 0.1. I don't know. It's small. And then let's say that this point right here, up here, is something like, maybe it's 0, not 0, maybe it's 0.1, and maybe it's 10 like that. Now, all I want to do on this is just show you what would happen on these things like this. So let's just use just these 3 points. Let's use 0.1, 10, 2, 2, and 10.1. All I'm going to try to do is just give you an idea on a special case of what happens. So if you did the inverses, what you would have is 10 and 0.1. You would have 2 and 2. That's still the same. And then you would have 0.1 and 10. Now, if you look at this, if you graphed these 3 points that I'm highlighting in blue there, what would happen? You'd have the same thing, wouldn't you? I mean, you would have these same points right here. So sometimes an inverse, the graph of an inverse is the same thing. If you plotted these 3 points, look at it. They're here. They're already there. So we're not changing anything really. And the same thing would happen over here if you did that. Well, how can I tell that? If you did that dashed line again, y equals x, let me ask you a question. Is that graph I gave you, isn't it already symmetrical?
Yeah.
Okay, it is. It's already got that symmetry. So if you fold it over that dashed line, it's going to come together like that. Okay, so that's the idea. So that'll be a good stopping point for today. And what everybody needs to